Yeah, good morning children. See, already in our previous class we studied various steps involved in metallurgy, extraction of metals. See, in our earlier class we studied how to extract the crude metal by different methods. In this session we will learn how to refine. Though you got the crude metal, but still it has some impurities. So how can we remove these impurities from the crude metal is nothing but refining the metals. What is that? Refining. What is refining? Extracting or purifying crude metal to get pure metal. So in our previous class we studied how to get the crude metal. Now after getting the crude metal, that crude metal also has some impurities. So elimination of those impurities from the crude metal is known as what we call it refining. Fine in the sense, what does it mean? Refine. To get the 100% pure metal. Okay, so to eliminate all the micro impurities that are present in the metal is nothing but refining. Are you clear? So what are the stages involved in refining? What are the methods we follow? The first one is distillation. What is that? Distillation. Second one, polling. Third one, electrolytic refining. The fourth one is liquefaction. See, which method we have to adapt to get the pure metal depends on the nature of the metal and nature of the impurities present. I told you first two stages are common. From reduction onwards, the process are completely changed depending on the nature of the impurities and depending on the nature of the metal. In the same manner, refining also changes according to the impurities and nature of the metal. Are you clear? So what are the four methods we adapt? First one is the distillation. Next, second one is polling. The third one is electrolytic refining. Next, the fourth one is liquefaction. Whatever the order may be, these are the four methods we adapt to refine the metal. Okay, so let us discuss one by one. Distillation. Here, what is meant by distillation? When do we adopt this method? For which metals we adopt this one? Okay, first we make a note of it. Metals like, for the metals like zinc and mercury and cadmium. What are that? Zinc, mercury and cadmium. Okay, see, these metals are refined by a process known as distillation. So we adopt this method whenever there is the difference in the boiling points between the metal and impurities present. When there is a difference in the boiling points, of metal and impurities, we adapt this method, that is distillation. Are you clear? For example, you take the case of zinc. You take the case of zinc. See this one. Its boiling point is 907 degrees centigrade. Okay, next you take the case of mercury. Boiling point is roughly 353 degrees. See, I am writing the nearest values, not the exact values. These are the nearest values. Boiling point of zinc is 907 degrees centigrade, and mercury is, the boiling point of mercury is 353 degrees centigrade. Are you clear about that one? Now, but the impurities present in these metals, zinc, mercury and cadmium, their boiling point of impurities, is greater than 1200 degrees centigrade. 1200 degrees centigrade. So, when this metal along with the impurity is taken in the retard, this is the retard, the diagram is not given in your textbook. This is the retard. This one is the condenser. Next, pure metal. Now listen to me. This crude metal is taken in the retard and is heated. As you know that, as I told you, these metals will have low boiling point. They gets vaporized, and the vapors are collected at the top and is sent through the condenser, and they are cooled, and the pure metal is collected in another vessel. Are you clear about that one? So because of the low boiling point of these metals, first they are vaporized. Those vapors are condensed. Are you clear about that one? Those vapors are condensed and you will get the pure metal. This is the pure metal. Are you clear? And the impurities are left over at the bottom. Impurities are left over at the bottom. Are you clear? So this is the volatile substance, and these impurities are the non-volatile. Because they are not easily vaporized because of the high boiling point of the impurities. Only the metals, because of their low boiling point, they get vaporized, and those vapors are condensed and they are collected in a separate chamber. Are you clear? This is the process known as, what we call it, this process is known as distillation. We adapt this method whenever there is the difference in the boiling points of either the metal or the impurities. Try to understand, either the metal or the impurities. Are you clear? The metal or the impurity which has low boiling point will get vaporized. It gets vaporized. Okay, and those vapors are collected and they are cooled. Are you clear? You will get the pure metal. Okay, and impurities are left over at the bottom of the retard, at the bottom of the retard. Are you clear? This method is known as what we call it, distillation. Distillation. Okay, for example, you take the case of water. Water boils at 100 degrees centigrade. Are you clear about that? So it vaporized. Are you clear? So when you collect those vapors, again you will get the liquid, pure water is collected. In the same manner, in this method, the metals will have the low boiling point, and the vapors are collected. Because of their low boiling point, they get first vaporized. And those vapors are collected, and impurities are left over as non-volatile substances. Okay, make a note of fouling. What is that? Okay, this is the oldest method. In this method, what we are doing, we are constantly stirring the molten metal, crude metal, with the help of green logs. If any oxides are present, they are expelled as gases. Generally, copper metal is purified by this method known as fouling. Are you clear? We use this method. To refine copper metal, crude copper metal. If any oxide that is like cuprous oxide is present, oxygen is expelled, that is impurities are expelled as gases. So in this method, in your textbook also, for this one also, no diagram is given. Okay, see, crude metal is taken, in the molten form is taken in a big containers. This crude molten metal it is continuously stirred with the help of green logs. What are they? Green logs. Okay, it is continuously stirred, stirred. Okay, so to get the pure copper metal, this method is known as what we call it, fouling. Are you clear? This is the oldest method. Are you clear? So generally we use to get the pure metal copper, okay, from Bristol copper. We call it as Bristol copper. Are you clear about that one? Okay. So what is fouling? Fouling is nothing but stirring the molten metal, crude metal, continuously with the help of the logs. Okay, if any impurities are present, they are expelled as the gases, and water vapor is present, it is also expelled as the water vapor. Are you clear? Do you understand the concept? Okay. Is liquefaction. See, we use this method to refine metals like tin and lead. Metals like tin and lead. Metals like tin, stannum, and lead are refined are refined by this method. See, we use this method whenever there is a difference in melting points, either the ore or the impurities. When there is the difference in the melting points of the impurities and the ore, of the crude metal, then we use this method known as liquefaction. What is that? Liquefaction. In the beginning I told you distillation is when there is a difference in the temperatures, that is boiling points. But this method, when there is a difference in melting points between the crude metal and the impurity present in it. So metals like tin and lead are purified by this method known as liquefaction. In this method, what we are doing, we are taking the metal on a slopy surface, this is the crude metal, and this crude metal is allowed to pass through a slopy surface which is heated with the help of the furnace. This is furnace. So because of the low melting point of this metal, metals are collected here and impurities left over there only. They stick to the surface. Impurities are left over there and the metals are collected here. Because of the low melting point, the metal first melts, pure metal melts. Okay, you will get the metal, pure metal, and the impurities are collected there only. Okay, they are left over here only and pure metal is collected here. Are you clear? So when there is the difference in the melting point of the metal and crude metal and the impurity, we adopt this technique. This method is known as liquefaction. Are you clear? So I told you 3 methods of refining the metal. Okay, go through your textbook and read once again what I told you. Okay, are you clear? In your textbook you didn't find any diagram for this one, any diagrams. Okay, simply has given the definitions, that's all. Are you clear? No need to write the same metals. You can choose another metals also which have the low melting points. Are you clear? Right.